So today's lesson is on inductive reasoning and conjecture. So we probably need to define those terms. So the first one that I want to define for you is inductive reasoning. Inductive reasoning is reasoning that uses specific examples to arrive at a particular conclusion. So this is inductive reasoning. Okay. A statement that is reached when you use inductive reasoning is called a conjecture. An example that contradicts or proves a conjecture to be false is called a counterexample. So, inductive reasoning, conjecture, and counterexample. So the first thing that we're going to do is write a conjecture that describes the pattern, and then use your conjecture to find the next item in the sequence. So the first thing I see is the number 2, and then the next number is 4, the next number is 12, the next number is 48, and the next number is 240. So I originally thought that the conjecture would be each term is squared, so like 2 squared is 4, then 4 squared, but 4 squared isn't 12. So then I thought, well, what if I'm going to take each term and multiply it by, for example, 2 times 2, well, that would give me the 4, and then the next number after 2 is 3. 4 times 3, well, that would give me 12. The next number that comes after 3 is 4, and 12 times 4 happens to be 48, okay? So then I'm going to do 48 times 5, and that equals 240. Oh, perfect. So now I'm going to do 240 times 6, which is 0, 4, 6 times 2 is 12, plus 2 more is 14. So the next number in the sequence would be 1,440. But we really haven't made a conjecture. We just discovered what the pattern is. So we could say that each term is multiplied by x, and then x plus 1, and then x plus 2, and we let x equal 2, right? Because that's where we started. So that could be a conjecture if we wanted to say it algebraically. We could just say that each term was multiplied by 2, and then 3, and then 4, and then 5 sequentially, and that could go on forever. So that is an example of a conjecture. All right, example B says to write a conjecture that describes the pattern shown, and then use your conjecture to find the next item in the sequence. So this is actually not drawn for you, so I'm going to draw this pattern for you. You would actually have to draw this on the board. So this is my first one, and then my second one looks like this, and then my third one looks like this. So you have to make a conjecture to discuss the next item in the sequence. And there are numbers below each one of these. This one is 3, this one is 9, and this one is 18. So using this picture, so make sure you pause or something so you can draw these, but using this picture, make a conjecture to find the next item in the sequence. So let's see, I'm just going to do some thinking. Well, the first thing I did was I added 6, and then the second thing I did was I added 9, and it just so happens that each triangle has 3 sides. So this was actually an increase of 3. So if I follow that same pattern and add 3 more, then this should be 12. So 18 plus 12 would give me 30. Now let's just count. This number came from the number of sides, 1, 2, 3. This number came from the number of sides, 1, 2, 3, 4, 5, 6, 7, 8, 9. This next number, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So if I had to draw an image, it would be a nice triangle with 1, 2. It looks something like this, right? Ooh, hang on a second. I need to undo that. So this next one, let's see, 1, 2, 3, 4, 5, 6. Okay, so I think that would give us 30 here, 30 sides. So if I were to count those, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. So that works. So what is the pattern? Well, the sides increase by 6, and then 9, and then 12. So they're increasing by a multiple of 3. The other thing that I noticed is that the number of triangles, if you were to count the triangles, this is 1 triangle. I'm going to use a different color. This is 1 triangle. This is 4 triangles, 9 triangles, and 16. So I also noticed that the number of triangles is a perfect square. I mean, it just asks us to make conjecture, so that's something that I noticed as well. Okay? So example C asks us to make a conjecture about the sum of odd number and an even number. So it says that the sum of an odd number and an even number. So let's just try an odd number and an even number, an odd number and an even number, odd number and an even number. Let's see. Well, when I take an odd number and add it to an even number, I think I get an odd. Does that work for 5 plus 6? Does it work for 7 plus 8? So the conjecture that I'm going to make is that the sum of an odd number and an even number is always odd. Now, if you wanted to say that that was not true, you would have to provide a counter example to show that that was not true. All right, let's look at example D. Example D says for points L, M, and N, LM equals 20, MN equals 6, and LN equals 14. So let's see. If this is M, and this is N, and MN equals 6, and this is L, and this is N, and LN equals 14. Make a conjecture, let's see. But LM equals 20, so I actually need to maybe do this way. So this is L. LN is 14, and then that means that LM is 20. So make a conjecture and draw a figure to illustrate your conjecture. Well, my conjecture is that points L, M, and N are collinear with in between L and M. Now, I don't know if you were paying attention, but when I originally drew that, I drew it like this, making this M, making this N, and making this L. And the way that I had it drawn was like that maybe this was a right triangle, but I could just make this any triangle, right? I could make this any triangle. It doesn't necessarily have to be a right triangle. I could do something like this, where this is M, this is N, this is 6, this is 14, this is L, and this is some crazy obtuse triangle, and this is 20. But we're going to learn, or hopefully maybe you already know, that the triangle inequality theorem says that like if you're trying to find sides of a triangle, the sum of two sides has to be larger than the third. So this would not really actually make a triangle. This number would have to be greater than this sum, okay? So this picture is good. This is my conjecture. So in example E, it says the table shows that the total sales for the first 3 months that a store is open, and the owner wants to predict the sales for the 4th month. So make a conjecture about the 4th month. Well, the first thing that I did was I looked, and it seems like the sales are 3 times greater in the 2nd month than they were in the 1st month, and they're 3 times greater in the 3rd month than they were in the 2nd month. So if I were to make a conjecture using this same model of 3 times, then I could predict that the sales would be 13,500 in the 4th month. But my question is this realistic? Do you feel like, I mean, especially if it's like a new store opening or something, do you think that the sales are always going to be 3 times greater than the month before? Probably not. We're just making a prediction, so we've done that, okay? All right. So your lesson for today is on page 94. This is lesson 2.1, and you are going to do 8, 10, 12, 13, 16, 32, 34, 40, 41, 45, and 57. That's 11 problems, okay? So that will actually be due Thursday. So for those of you that took time in class today to finish your test, you're going to have to watch your lesson and complete the homework all tonight, okay? All right, thanks.